Today I'm going to start with Knuth Pratt string matching algorithm. This is linear time algorithm, which is very popular string matching algorithm and very popular from AKTU point of view. I'm Dr. Rajesh Prasad, working as professor of CSC, Ajay Kumar Garg Engineering College, Ghaziabad. So four major algorithms in this string matching category. First one is Neo algorithm, which is called as a brute force algorithm. So this is also known as brute force algorithm. Brute force approach, like it is very classical algorithm. And second is KMP, is a linear time algorithm, given by Knuth, Morris and Pratt, right? So, and third category is string matching using finite automata. This is also very easy algorithm. And fourth category is Karp and Rabin algorithm, right? So, as we know that the string matching is very popular. So, why string matching is important? Let me just introduce little bit. So, this is actually very popular in text editing program. Like, see, everybody have seen that if you just use control plus find, you will see that you can easily get the the string which you are looking for. Or we can see that control find and replace, right? Find and replace program. They are only possible because of the help. They are only possible with the help of the string matching algorithms, right? So what is happening over here? Typically the text is a document being edited and the pattern is a word need to be searched in the document. It's very classical algorithm and it is coming since beginning, like beginning of the computer. And you see there are efficient algorithm for this problem. And but we have many efficient algorithm. Still research is going on this efficiency. So one important thing, if you might have noticed that Notepad and Microsoft Word both have this facility, right? Both have this facility of the find pattern inside the text. But there is difference between Notepad searching and MS Word searching, because Notepad searching is not searching for the blank space. For example, if you are given like see Rajesh Prasad, right? Microsoft Word can search H space P also, but Notepad search will not search this HP. As you are encountering the blank space, Notepad search will eliminate. It will not work at all, right? So so let's have this. So what is like search and what is string matching? So basically here we have a text T from 1 to N and pattern P from 1 to M. This where M is length of N. So generally problem of this like string matching is to find out all the valid shift. What do you mean by valid shift? Such that valid shift yes is any number, right? Yes is a number ranges from 0, 1 up to and so on n minus m. This is any number which is ranging from 0 to n minus 1 such that T of s plus 1 S plus 2 up to and so on S plus M equal to pattern of 1 to M. We are assuming that pattern and text are represented from 1 to M, right? One is starting from 1 to N. Lower limit of text and pattern we are assuming from 1. See, let's see. Suppose this is text and this is pattern. We can see that A, B, A. This is going to be equal over here. All the characters should be matched, right? So if this is situation, that means we have valid shift of 3. 1, 2, you see here we can start 0, 1, 2. So we start from here. So here up to 3, right? So valid shift is going to be 3. So string matching problem is actually to get all the valid shift in the text, right? So New algorithm is very easy, that we are looking for all the valid shift one by one. So what is happening here? If this is pattern AAB, we start looking for shift equal to 0, right? So if you check, it is equal, but there is no equality on C and A. That means this is not a valid shift, right? Yeah. Let us see, then increase it. Once we are getting that no valid shift, you just increase to the next point. Let's say S equal to 1. So there is no validity, it is not valid. So S equal to 1, even we are failing from the beginning itself, right? So next S equal to 2, you see here there is a validity, that means S equal to 2 is a valid shift. So this is a valid shift, right? Yes. And S equal to 3 is not valid because we get it over here, and like this is not equal. So that means this algorithm is like finding out each and every valid shift by comparison of the pattern and text character, right? So one important note, that see this, if you have ACAABC, right? It's not necessary that we should start checking from the left itself. We can start checking from the right itself. See, AAB is like, it is not necessary in new algorithm that we should start from left to right. We can also start from right to left, right? See this, there is no matching, you can discard it. There is no problem, right? Yes. So then ACAABC, then again you can go on AAB. There is a matching, there is a matching. That means yes, this is valid shift, right? And the shift will be calculated from the beginning itself. Shift is still going to be 2. Shift is still going to be 2. It doesn't matter whether we are comparing from the right or comparing from the left, right? Then ACAABC, we can also compare from right to left. No, there is mismatch. No, it is not going to be the valid shift, right? So same thing, ACAABC and then AAB. No match, that means it is going to be discarded. So only one match is going to be found. So simple, that check all the matches from 0 to n minus 1 and then compare them one by one. Its meaning is that everything should be equal. All the pattern characters should be equal to the text character. But why it is not like important, like not like a very good algorithm? Because this is actually not working if you have overlapping character. Like see, suppose I am having text equal to ABC AB. You can see that AB ABC AB. Suppose this is your text, right? ABC AB and C. This is overlapping. You see ABC ABC and this is overlapping, and pattern I am checking with ABC AB. So you see here one matching is over here and the other is also over here. So there are overlapped matches. What they will do, they will compare one by one. So that means this suffix and prefix information, this overlapping information is not going to be encountered by the new algorithm. So KMP is very good algorithm which is taking this advantage that if you have suffix and prefix of a pattern which is equal, that means KMP will take this advantage, while new algorithm will not be able to take this advantage because this is just comparing left to right one by one. It is not storing any information whether some part of the pattern is matching into the text, right? So that is how we are going to discuss about KMP algorithm, and it is very popular, very important algorithm. So the time so just like see this, the time complexity of KMP algorithm will be linear in nature, right? Yeah. And definitely this is better than the Naive algorithm, where Naive is taking like order of m this time. So, and one more drawback of Naive algorithm, suppose you have a pattern like here, it is equal. but there is a mismatch over here. So it is situation can be the like that all the character are matching, but there is a mismatch in the last character every places, right? So this is like extra work. Why we are comparing unnecessary if there is like mismatch in the last character? So this is not desirable algorithm. It will keep on searching and giving too much time. So what KMP is doing, this is using pre-processing steps, right? This will include the pre-processing step as well as searching step, right? So pattern over here is going to be pre-processed first, then we are using the searching algorithm. So in this pre-processing, algorithm is computing a prefix function for the pattern. Prefix function for the pattern, right? Yes, this is going to be prefix function for the pattern. So this prefix function pi is going to be computed for the pattern, and then pattern is going to be thrown away. No need of that pattern, right? So this is okay. So what is prefix function? So what is prefix function? Pi q. Prefix function for pi q. And what is q? Q is like any number. See, so pi q is the length of the longest prefix of p pattern, that is a proper suffix of pq, right? So this is like pi q is defined as, see, so pi q is length of longest prefix of p, length of longest prefix of p, prefix of p. P stand for pattern, which is proper suffix of pq. Clear? This is how we are going to compute, and so q number will be from 0 to, and this q will be 0 to pattern length minus 1. This is the length of q. So suppose you have a pattern ABA. Suppose we have a pattern like C, ABA and BACA. Clear? So I'm having this pattern. P is ABA, BACA. So what you should do? Make a table, right? Make a table here, and like I is 1, 2. This is the table, and this is pi prefix function, and this is the pattern. Clear? Yes, I is 1, 2, 3, 4, 5, 6, 7. We can place pattern over here A, B, A and B, A, C, A. Clear? Yes. So we are interested in computing pi 1. Let us compute pi 1. So in order to compute pi 1, see this definition. Pi 1, we are placing 1. Length of longest prefix of p. This we are going to check over here, which is proper suffix of pq. So we are going to check proper suffix of p1. So what are the suffixes of p1? A. P1 is here A. What are its proper suffix? Epsilon, right? This has only two suffixes, A and epsilon. It has two suffix, epsilon and A. But if you are interested in only proper suffix, which is epsilon, and this is already going to be here, right? Yes. So its length is going to be 0. Its length is going to be 0. Yes, this is the length. Yes. Similarly, Similarly, let's compute pi 2. If we are computing pi 2, so first, in order to compute pi 2, we have to find out proper suffixes of P2. Here, P2 is AB, right? So its proper suffixes are B only. And B is not going to be found in the prefix of P. So it is still going to be 0, right? Yes. So it is going to be 0 here. Yes. So same thing, if you talk about computing pi 3, so you just check this, right? Yes, ABA, its proper suffixes are A and BA. Check which one of this is prefix of the pattern. So you know A is prefix, its length is 1. BA is not prefix, so its length is 1. So that is why 1 is going to be here. Same thing, if you are talking about here, AB, so if you just check AB, compute its proper suffixes, right? So its proper suffixes are like B, then AB, then BAB, and that is the proper suffix. And we know that this proper suffix B is not going to be part of the prefix. AB is part of the prefix. So its length is 2. So that is why it is written 2 over here, right? So same thing, if you just understand this ABA. Its proper suffixes are A, and then BA, then ABA, and then BA. So which proper suffix? A is also encountered over here. Its length is 1. B is not there, but ABA is also there. Its length 3. So we are interested in maximum suffix, proper suffix, which is prefix of the pattern, right? So it's ABA, that means its length is 3. Same thing here. If you just find out its proper suffix of up to this length, we will see that its proper suffix is C, then AC, and then BAC, and then ABAC, and then BAC. None of the suffixes are the prefix of the pattern. See this? None of the suffix, like C here. C is also not on C. C is not a prefix. Yes. This, so AC is also not prefix. BAC is also not prefix. None of them, they are suffix. So definitely epsilon is there. So its length is 0. Its length is 0. Same thing here. If you just compute the proper suffixes, only we will get A, which is length, which length is 1, right? So this algorithm is just computing the proper suffixes. Let's say this. This is also very good example. Many times it has been asked in the AKTU. So if you see here, this is the pattern and this is prefix function. Prefix function is very important to compute for every KMP matching. So if you just see this here, pattern is already given over here. So if you take part of this pattern, which is A, its suffixes are epsilon only. Proper suffix is epsilon only. So its length is going to be 0. So this is written over here. Same thing, if you take two portion AB, its proper suffixes are B only and epsilon. B is not matching as a prefix and only epsilon is matching as a prefix. So its length is 0. So this is going to be written over here. This is why we are writing 0. So same thing, if you just take ABA, right? 3 portion. If we take ABA, what are its proper suffixes? Its proper suffixes are A, then BA, and then epsilon. These are the proper suffixes. And which proper suffix is matching? See, we are interested in maximum. A is matching in the pattern. Pattern prefix. A is also part of the prefix. So its length is going to be 1. So that is why we are writing 1. So if you see here up to this length, right? So it's up to this length. Proper suffixes are B, AB, and then BAB. See, note that if none of the proper suffixes are matching, so epsilon is already there, which will match. So it's that length has 0. So now pattern. Look at the pattern. B pattern need to be processed from the left. B is not encountered, but AB is there. AB is there, so its length is 2. BAB is not there, so that is why we record 2 over here. Clear, class? Yes. So now, and if you just go here, it's like up to this point, A, B, A, B, B. Its proper suffixes are B, then BB, and ABB, and then BABB, right? So none of the proper suffixes are prefix of the pattern. None of the proper suffixes are prefix of the pattern. So epsilon is already there, so this will be 0. So this is how it is written as 0. So similarly, we can compute the prefix function for all the pattern, right? So this is also like this has been asked in the examination, BA, BB, AB, AA. Let's solve this. Yes, let's do this question. BA pattern is BA, BB, AB, AA, right? BA, BB, AB, AA. Okay, so same style. We have to prepare a table like this table. In all the questions, we have to prepare a table BA and then BB, AB, A and A. Clear? This is number 1, 2, 3, 4, 5, 6, 7, 8. 8 length pattern. And this is like I, and let's say this is pattern and this is prefix function. So prefix function need to be computed correctly, right? See. So if you are interested in pi 1 means this up to B, this B. So find out its proper suffixes, right? Find out its proper suffix like epsilon, and its length is going to be 0. So store 0 over here, right? Clear? Yes. So now you see, if you are interested in up pi 2, that means we are going to have pattern up to BA length, right? So BA length, this is pattern up to BA length. So its proper suffixes are A and epsilon. So look at here, A is not found as prefix of the pattern. A is not prefix of the pattern. So that means it is still going to be 0. Clear? Yes. So same thing, if you are interested in getting pi 3 is BAB, right? So it's like proper suffixes will be B, then AB, then epsilon. And look at here, which proper suffix is part of the prefix of the pattern. B is part of the prefix of the pattern, but AB is not part of the prefix of the pattern. So B length is 1. So that is why it is written as 1. So same thing, if you are interested in pi 4, what you should do, take the pattern up to 4 length. So this is BA, BB, right? Calculate its proper suffixes. Proper suffixes are B and then BB, then ABB, right? Check which proper suffix is part of the prefix. B is part, its length is 1. Yes. BB is not part of the prefix. BB is not there. Then ABB, it's not there. So its length is still going to be 1, right? Yeah. So same thing, let us take pi 5. If we take pi 5, so this is BA, BBA, right? So its proper suffixes are A, then BA, and then BBA, then A double BA, right? So which one is like maximum? A is not encountered in the prefix, BA is there, BA is part of the prefix, its length is 2. Yes, BBA is not there, it's not there, its length is 2, A double BA is not there, so this is going to be recorded as 2, right? So, okay. And now, let us talk about the pi 5, right? If pi 6, pi 6 is BABBAB. Find out all its proper suffixes. So B is proper suffix, then AB, and then BAB, and BBAB, and then ABBAB, right? So here B is yes, its length is 1, AB is not there, its length is, it is not going to be computed. BAB is there, right class? So BAB, its length is 3, so this is not going to be considered. We are interested in maximum length, right? Then BBAB, yes, not there, it's not there, then AB, so its length is going to be 3. Similarly, we can compute the pi 7. If we compute pi 7, find out pattern up to 7 length. So BA, BB, ABA, right? Yes. So its proper like suffixes are A, and then BA, and then ABA, BABA, and BBABA, and then ABBABA. Which one is part of the prefix? This is not. BA is part of the prefix, its length is 2. ABA is not there, right? BA is not there. Yes. Then BBA is not there. Then this is also not there. So its value is going to be 2. The last one is like this. You see, what are the suffixes of the last one? Suffixes are A, then AA, then BAA, right? And then ABAA, right? And then BA, B double A, and then BBA, B double A, and then ABB, ABAA, right? So which one is the prefix? A is not prefix, AA is also not prefix, B double A is not prefix. Then ABAA is also not a prefix, BAB double A, this is also not a prefix, BBA, this is also not a prefix, this is also not a prefix. So in fact, this is going to be 0. So this, I hope it is clear, right? So this is the prefix function for this given pattern. Similarly, you can also calculate prefix function of this pattern. So computing prefix function in the KMP algorithm is the major task, right? So after you have computed the prefix function, question is that how to get the matching. Yes. So see here. Suppose, so this is the algorithm. So let us have one small example of text, right? So let's say text is ABCAB, right? And A. Let us take this text. And pattern is like, let's say ABCAB. And text you can say like here, you can write like here. So if you see here, so definitely in this situation, you must get the prefix function for this pattern. So if you see the prefix function for this pattern, you need to compute, right? So you just compute the prefix function 1, 2, 3, just like we did it 4, 5. And pattern is A, B, C, A, B, and then this is pattern and this is pi. See, this is pi. So let us match it. Let us get the prefix function for this. Pi A, this is 0. Then we are taking AB and its prefix function suffixes are B and which is not encountered here. So this is 0. Same thing with C. Its proper suffixes are C, then BC and nothing. So C is not in prefix part. BC is also not prefix part. So this is 0. Same now here A, it is 1 because its proper suffixes are A and then CA and then BCA. So A is encountered into the prefix of this pattern. So this is here. Then AB is the maximum suffix which is prefix of the pattern. So this is going to be 2. So let us see. So this is pattern. So now you are going to discard this pattern after getting the prefix function. So n is length of the pattern n. So n is like 2, 2, 4, 2, 6, 1, 7. This is n is 7. We can see here that pattern ABCAB is matching over here. It's not like a big deal. Pattern length is 5. So pi is compute prefix function. So we have already computed. So we are taking help of the Q, which is like going to be initialized to be 0. Yes. We are going to take entire text BA, BCA and then BA. So you start from 1 and start from here, start from 1 here. Yes. Now at beginning this Q is going to be 0. So this is not going to work while Q greater than 0. No, it is not correct. If PQ plus 1, P1, PQ plus 1 means that P0, P1 is T1. No, P1 is not T1. P1 is like A, B, C, A, B. P1 is A and T1 is B. No, it is not correct, right? So this is also not going to be correct. And Q equal to M, it is not going to be correct. That means it is not going to correct. So I will be automatically incremented to 2, right? So yes. Remember, Q is still 0. So I is going to be here, right? Yes, I is going to be incremented. Again, Q, no, it is not greater than 0. Yes. So that means this is not going to work. Now, next PQ plus 1. Yes. Q is 0, P1 is A, and the T1 is also A. See here, PQ plus 1. Q is 1. Q is 0 and plus 1. That means we have P1 equal to T1. Correct. Yes. P1 is T2. Yes. I is 2 now. So P1 is A and I is 2. This is correct. That means Q is incremented to 1. Q1 is not equal to M. Correct. It is not equal to M. I will be again incremented. So now I is here B. Yes. So definitely B equal to next matching character. Yes, P2. Correct. Q was 1. See, Q is 1. So Q plus 1 is P2. Correct. P2 is here B. And T3. Yes, B equal to B. There is a match. So now Q become 2. Correct. Yes. 2 is not equal to M. Yes. So I become next character. Yes. I become C here. Q plus 1 P3. Yes. C equal to C. Correct. So Q become 3. Correct. Here. 3 is still not equal to pattern length. Remember here, this is not going to work. Q greater than 0, although it is there, but it was not equal. So that's why I'm not comparing over here. So now you see here it is equal. So I become 4. You see 1, 2, 3, 4, 5. I become 5. P5, T5 is like P4. Yes, correct. So now this Q is incremented to 4. Again 4 greater than, you can check that this is not going to be applicable. So now Q equal to 5. Correct? Yes, Q equal to 5. So you see here PQ plus 1. Yes, like PQ plus 1. Yes, P5. Correct. Yes, it is correct. P plus 1, like Q is like 1, 2, 3. Yes, this is correct. So Q is equal to 5. That means all of the matches are correct. So 5 equal to pattern length. Pattern length is still 5. This is true. So pattern occur with shift I minus 1. What was I? I was 1, 2, 3, 4, 5, 6, 7. I was 6. 6 minus 5 is 1. So pattern occur with this one shift. Correct. This is correct. Yeah. Pattern occur with this shift is correct, right? 1, 2, 3, 4, 5, 6, 7. I was equal to, yes. So this is like valid shift. So yes, so we got shift equal to 1. And after getting this shift, we are going to reset this Q equal to pi Q. That means we are interested in resetting it pi 5. So that if you have a part which is already like matched, so we should not be going it again and again. So what is pi 5? Pi 5 is 2. So that means now Q is getting 2. Clear? Q is getting 2. So what will happen? Suppose if you have again A, B, C, A, B. So you are already having Q equal to 2. So you are not going to match again and again. So this Q equal to 2 is going to be changed. So you see 2 greater than 0, and it will check if Q plus 1 is not equal to T. Again it will reset the value. On the other hand, Q plus 1. Q plus 1 like P3. So here see this P3. We are not checking AB. We are already checking this value. By this way, it is like very efficient algorithm. So you see that this algorithm is very popular, and we can. So you can also take some example where like pattern is not going to match. See this, like pattern is AB, C, AB, right? And text is like, you see, text is like AB, C, AB, and then again you can write here like AA, and B. You will see that same algorithm. If you just compute pi, right, and you just compute pi, and you will see that ABCAB, AAB, and after computing pi, what you should do, just start applying this algorithm, right? Once you apply this algorithm, you will see that this is going to update Q again and again. Yeah. So let's see this. Let's see this. Only it is going to capture this part and it will fail other. So let's solve this. Again, we are going to have pattern. Yes. So pattern is, let's say, ABCAB, and I'm just writing this here 0, and then this is going to be 1 and 2. What will happen, class? Q is like going to be 0. I is starting from 1. Q is start from 0, right? Yes. So Q greater than 0. Yes. So PQ plus 1 is not equal to Ti. Yes. It is not going to work because this is equal. This is equal. Look at here. This is equal Q plus 1 like P1 1 equal to T1. Yes, correct. This is equal. So that means Q is going to be 1. Same thing, it is not equal, so it will go back again. I equal to 2, right? Yes, it is not, it is equal, so q will be 2. Same, I equal to 3. Yes, I equal to 3. So if I equal to 3, so pq plus 1, p3 equal to t3. Yes, so definitely q is going to be 3. Clear, class? Yes. So then again this is equal, so q will be 4, and this is also equal, so in this situation q will be 5. Clear? So here 5 equal to pattern length, correct? 5 equal to pattern length. So pattern occur with this, so shift is not a problem. I is 5, 5 minus 5 is shift, so this valid shift is being created, shift equal to 0. So shift is 0. Now what is next? After getting this shift, you have to reset the value. Q is pi 5. Pi 5 is going to be, pi 5 is going to be 2, pi 2. Sorry, pi 5 is going to be 2. So this value q is going to be 2. So now q is 2. Clear? This is where we are getting. Now again we start again. I is still remaining. These characters, 3 characters are remaining. 3 greater than 0. Yes, correct. Q is 2 here. 2 greater than 0. Clear? And PQ plus 1. 2 plus 1. P3. Let us say P3 not equal to T of this. 1, 2, 3, 4, 5, 6. T of 6. Yes, let us check it. P3 and T6. P3 is C and T6 is A. Yes, correct. This is correct. So that means Q is going to be reset to pi Q. So Q is pi of 2. Pi of 2, this is 1, 2. Pi of 2 is going to be 0, right? So Q is going to be 0. So that means again, so I is still going to be the next one, A. Yes, so you know here Q greater than 0, no, Q plus 1. So Q plus 1 means A equal to A. Yes. So here is going to be Q equal to 1. This is going to be 1. Again go back again. Next one. See. 1 greater than 0. Yes. 1 greater than 0 and Q plus 1. Like P2. P2 is not equal. P2 is equal to T1. Yes. So Q is going to be 2 here. Right. So this Q, so that means it will start matching from here. So thank you.